In this video, we are going to reveal a few interesting algorithms which have actually changed the internet world. The world where you search for something and it gets you most relevant results on top. The world where you think about something and that something pops up as a suggestion in the social media platform and you're like, how is this possible? The world where security is equally important. The world where AI is able to lead the path because of that one algorithmic factor and the correctness of answers that it generates. So today we'll make you aware of 5 remarkable algorithms that didn't just improve technology, they reinvented our digital lives. We are Basic Strong, and let us now show you how code became the most powerful force on earth with simplest and high-level explanations, so you don't need to put a lot of brain to understand these. On number 5, we have PageRank algorithm. Ever wondered how you're able to find most relevant results on top when you search for something on Google? Even on early days when I started using internet, to me it was the most interesting thing about Google. This PageRank algorithm is one of the main factors behind that. In late 1990s, as the web exploded with millions of pages, users had no reliable way to find the best content. So search results were chaotic. Then Google came up with this PageRank algorithm, and it's named after Google's co-founder, Larry Page. PageRank algorithm ranks the web pages based on their importance. But how that importance is measured? Let me explain you. PageRank is based on the idea that important websites receive more links from other websites. The algorithm mainly considers 2 things. One is number of links and another is quality of links. So the more links a web page receives from other websites, the more important it is considered. And these links are treated like a kind of vote. Quality of links, it's not just the number of links that matters here, but also the importance of the websites that are linking. A link from a well-established and reputed website carries more weight. For example, imagine there are 3 websites, A, B, and C. Both websites B and C links to website A, then website A is considered more important because it has received 2 votes. Now suppose website B is very important and popular while C is not as significant. So in this case, the link from website B will have greater impact on A's ranking than the link from C. Moving to the next algorithm, on number 4, we have JPEG Compression. Do you know if we have an image which is not compressed at all and at its full quality can be up to 10 times larger than JPEG compressed version? In early 1990s, digital cameras and the web was hungry for images, but uncompressed photos ate up megabytes and sharing was painful at that time due to their large size. Then came our hero JPEG, and interestingly, the most interesting part about JPEG is that it exploits the nuances of human eye to remove the information that our eyes cannot perceive. Cool, isn't it? Yes, human eyes are not perfect. Human eyes are more sensitive to brightness or luminance than the color, and JPEG takes advantage of this fact because our eyes have 2 different types of light receptors, rods and cones. Rods are critical for seeing in low light conditions, and cones, they are color receptors of red, green, and blue, and that's why they are color sensitive. In our eyes, we have 100 million rods, whereas only 6 million cone cells. Let me show you the luminance image on one side and the color at the other side. So all the details of the image we are able to identify in the luminance image, and when even we are not having complete color information, our brain itself fills up the gaps. JPEG takes advantage of this fact and does lossy compression that shrinks photo files by up to 90% without noticeably harming the quality. As a result, you get seamless photo sharing on Instagram, Facebook, and beyond. Your gallery never fills up overnight. Remember, we are hiding the mathematics and the step-by-step process behind JPEG conversion. But if you want to dig deeper in any of the algorithms that we are explaining, let me know in comments. Next, on number 3, we have RSA encryption. And this is literally savior of your data. It protects your data from sneaky hackers. By the late 1970s, as online banking and e-commerce emerged, sending credit card numbers in plain text was a recipe for disaster. RSA is an asymmetric encryption scheme that uses a public key to lock the data and a private key to unlock it without ever sharing the secret key. And this technique was first publicly described in 1977 by Ron Rivas, Adi Shamir, and Leonard Edelman, and that's how it's named RSA. On high level, if I explain it, it's based on the idea that while it's easy to multiply two prime numbers together, it's extremely difficult to reverse the process and figure out those original primes from the result, especially when the numbers are large. These two prime numbers are used to create a pair of keys, a public key and a private key. The public key is used for encryption, while the private key is used for decryption. What's crucial is that these keys are generated as a pair. So each public key has a matching private key, and it's practically impossible to derive the private key just by knowing the public key. Now let's say person A and person B each create their own key pairs. So they only need to share their public keys over the internet. Even if someone intercepts these public keys, they're useless for decryption. Only the person with correct private key can unlock the message. So if person B wants to send a secure message to person A, he can use his public key to encrypt it. Since only person A has the matching private key, only person A can decrypt it. The same goes the other way. Person A can use person B's public key to encrypt the message, knowing only he can decrypt it. Moving on, next we have at number 2, backpropagation. This is that one algorithmic factor behind precise answers generated by AI. Generative AI, which nowadays don't need an introduction, it uses transformer architecture, which uses neural networks. Early neural networks in the 1980s struggled to learn effectively until the backpropagation algorithm arrived in 1986. Backpropagation is simply the process where a neural network goes back and tweaks its settings based on the errors it made, helping it get better and smarter over time. On high level, how it works, there's a forward pass where input travels through each layer to produce a prediction. And then there is error measurement, where prediction is compared to the true answer to calculate the error. Then there's backward pass, where error is propagated back through the network, tweaking each weight proportionally. And then this process is iterated millions of times over diverse data, which is how AI keeps becoming smarter and smarter. As a result, today, it powers everything from facial recognition to real-time translation and superhuman game-playing AI. Moving on number 1, we have collaborative filtering. Ever noticed how social media seems to read your mind with product suggestions? Or ever wondered how Instagram seems to just know what reels you love? Or sometimes the products that are suggested to your friends are suggested to you too. It's not magic, it's called collaborative filtering. Collaborative filtering predicts what you'll enjoy based on the behavior of millions of users. No need to analyze every video or product. Here's the quick idea. When you first join, Instagram shows you a mix of popular content. As you start liking, watching, or skipping reels, the app picks up on your taste. Let's say you love travel reels and keep watching them, then Instagram notices that and shows you more content that other travel lovers with similar interests enjoy too. So that's collaborative filtering, either matching you with similar users or finding patterns between the kinds of content people like together. It's how Instagram learns what to show you, without even knowing what the reel is about, just based on how people interact with it. And yep, this tech powers more than just reels. Netflix, Spotify, Amazon, they all use it too. So let me tell you the steps on a high level. When a new user comes, there's nothing or much information about that user into the platform. So there's trending boost where new users see popular items first. Then comes behavior tracking. The system logs what you watch, skip, like, and share. And then comes two ways of filtering. One is user-based filtering and one is item-based filtering. If you've noticed the reels suggested to you which has this tag saying people like you also liked, so that will be shown to you, which is user-based filtering. Then there's item-based filtering where you see users who enjoyed this also enjoyed that. So that's how it works. It analyzes people, it analyzes the people with similar interests and then accordingly shows you the content. So next time you discover that perfect reel, thank the algorithm and everyone out there with great taste like yours. So those were 5 interesting algorithms that have in one way or another reshaped our digital world. We've kept the explanations at a high level for now, but if you'd like us to dive deeper into any of these, or if there's another tech topic you'd like us to get to the root of, just let us know. If you enjoyed this deep dive, hit subscribe and ring the bell icon so you never miss a video that makes you go, aha, see you next time.